My laptop has obviously had too many beers in advance. Anyway. So governments around the world spend a great deal of money creating and preserving beautiful environments. And when we're really busy with our work schedules and we're like desperate for a break, we often seek out these beautiful places to boost our well-being. And actually the reason I'm interested in beautiful places is that I do research where I look at how beautiful places might have a quantifiable impact on our well-being. And I'm not going to go into that in detail. I'm happy to talk about the research over beers later. But I'm basically going to be talking about, so just to say that the one thing I have found is that beautiful places are linked with people feeling healthier and happier. But I'll talk about that over beers later. But the question with this talk that I want to address is, the question is, what makes a place beautiful? And when we usually think of what makes a place beautiful or what a beautiful place is, we tend to see these kind of these beautiful natural landscapes that look like this or that might look like this. But what about beautiful cityscapes? What environments in the city are also beautiful and might be worth preserving? But the question is, well, how do you measure this? And that's quite tricky. But luckily, these days, we spend a lot of time online, and the internet has been a great source for gathering data. And one of these websites these online sources I found really helpful is this website called Scenic or Not. And it's this really simple online game people play, and they rate these images between 1 and 10. But what's happening in the background is each image represents a square kilometer of the United Kingdom. So I basically have about 217,000 images of all around Great Britain, and that have been rated about 1.5 million times. So, okay, there's a lot of images. Now, how do I go about actually analyzing the composition of these images? And well, this is where deep learning comes in. So if anybody here doesn't understand what deep learning is, all you need to know is that these models they basically mimic how we think the neurons in the brain might function. And these deep learning models are really good at learning, in a very real sense, patterns from images or sounds or anything that you might be able to code into some kind of digital representation. So, and they're like, for example, that's why we have this kind of, they're really good at facial recognition. They're really good at image classification as well. So one of these deep learning models I use is this deep learning model called MIT Places. And this model has actually learned to look at images and to recognize the place category, for example, the skyscraper versus a coast, as well as other attributes in the picture. So it'll tell you, is it a man-made? Are there man-made elements in there? Are there natural elements in there? Is there a faraway horizon? So what I did was then I took my 217,000 images and I ran it through this deep learning model just to see what comes out. So what I've learned is that the most scenic images, they tend to correlate with what we can imagine as these like beautiful landscapes. For example, coast, like the valleys and mountains, and like beautiful forest scenes. But that's not the only story. Actually, built-up features can also be rated as scenic. So I also noticed that some of the features that are getting picked up are like historical buildings, like castle, and like beautiful building types like a lighthouse, as well as bridge-like structures, so like viaduct and aqueduct. And if I look at what images are not scenic, then unsurprisingly, we get these images like these built-up industrial images, we get highways, but the story isn't that simple, because I've also noticed that just flat grass gets rated as unscenic. So it's quite, it's not as straightforward as we might think. So, so back to scenic or not, I've got an image and it's on a square kilometer basis. But I told you before that I'm actually interested in understanding the link between beautiful spaces and well-being. And I'm especially interested in understanding what that's like in the city, because we basically all live in the city, and we don't have the luxury to always escape to the countryside, when we want to boost our well-being. So in order to do that, I need images. I need to understand kind of beauty and scenicness on a higher resolution. So what I thought is like, what if I could actually train one of these deep learning models to actually predict the scenicness from the images? So the way I do that is we use a technique called transfer learning. And it's really handy because if you want to train a deep learning model from scratch, you need millions of images. But what you can do is remember the places deep learning model that I had before. So it's already very good at recognizing places. It's already good at understanding scenes. And what you can do is you can just kind of change it just a tiny bit, and you can train it to do a task that's quite similar. So now with my scenic deep learning model, it can actually predict the scenicness of images. And it does it with about 0.66 accuracy, which is a Kendall rank correlation. So it's not perfect, but it's not bad. So what I did was then, I want to see like what's going to happen with images in London. So there's a website called Geograph where people upload these images all around, again, Great Britain. And I took all the images in London and I ran it through my new scenic CNN that I've trained to see what it comes out with. So one of my favorite places, my favorite scenic space in London is Hampstead Heath. So I wanted to see like what does this model, what's it going to come up with? So so gray is not scenic, green is scenic, and purple is super scenic. So if we look at what comes out all around Hampstead Heath, it's picked up that it's actually a beautiful area, and it's actually quite even it has like super scenic purple dots as well. And if we look at central London, so that's an image of one of the pictures that got rated as being scenic. And if we look at central London, we see, again, some of the parks that we like to hang out with that are actually coming out, as well as things like Regent's Canal. So we kind of got the little path around Regent's Canal and around the Thames and all the kind of parks that people like to go to as well. But again, it's not that simple. If we look at Tower Hill, this is a built-up area. There's no parks here, and it's still even picking that up and rating it as scenic. And for example, it's basically picked up on the Tower of London as well. So, so just to summarize, so the definition of beauty or of scenicness is actually a little bit more complex than this natural is beautiful explanation. And natural features might not be thought of being scenic or beautiful if they're largely flat. So this, this flat grass lacking in trees or valleys is considered to be not scenic. But also, built-up features can also be very scenic and beautiful as well. So that's it.
Many thanks for the beautiful talk. Any questions? There is one.
Are there any images which have surprised you, which to human eyes are not very scenic, and then identified as scenic?
Not really. I guess because it's been trained on things that humans have rated. That is, I was just surprised because I didn't look at the images myself. But the fact that it picked up statues as being beautiful, I found a bit surprising. But again, it's because it's human rated, and I've only taken images that have been rated at least 3 times. So there's kind of no way, not necessarily a surprise. But I was surprised that it picked up on built-up features.
Yeah?
Have you tried adding more ingredients to your machine learning model, like for example the spatial density of the photographs, or some exit data, like the luminance of the scene or something?
So in the past, I've basically created kind of spatial regression models to predict scenicness as well, and then I've tried a lot of different kind of features. I'm trying to remember what really came up. I mean, I wasn't finding anything that concrete. So you think that if there's more green in an image, it would come up as being scenic, and that really wasn't this case. So I wasn't finding anything that strong. But this is a deep learning model. And unfortunately, with these models, they're quite black box. So you don't actually know what is actually picked up on. But
have you tried doing it with human beings?
so this come up. So this all the training data is all human rated.
Yeah, but like pictures of human beings.
Oh, I see. I don't even know if I want to go there. Yeah. I think, it would be quite scary, kind of like what you come up with. Oh, yeah. Yeah.
Next one.
Just like with people, you can have unflattering pictures and flattering pictures.
Yes.
I can take flattering pictures of scenery or time of day, time of year, weather. Is that something you've looked at?
I haven't looked at that specifically, but I'd love to have, because I don't have the same image as taken in the same place, but I would love to test that. So for example, clouds does come up with being associated with not being scenic, and that's not surprising because if it's cloudy, things tend to not look good. But yeah, I mean, I would love to have training data where it's exactly the same image, just taken perhaps in different settings. So for example, if it's a beautiful building, but there's a bunch of ugly vehicles around it, that's probably going to ruin the scenic rating. So.
Two more questions?
So more of a kind of statement. I mean, I think it's really interesting, and I think if you could get access to it, the pictures from Google Street View might give you a set of test data which isn't biased by humans trying to make the picture beautiful, because Google isn't really trying to make Street View beautiful. I think the challenge would be getting the pictures.
Yeah, actually, you can get the pictures, and I am looking at it. Yeah, I'm finding it a little bit trickier to train the deep learning model to kind of get understand those images. I'm not sure why, but I'm kind of working on. That's what I'm doing.
Last one. Yeah. Sorry, yeah. That's why there is a hard one.
You say your data is 1 picture per square kilometre?
Yeah.
Doesn't that underrepresent cities, since cities are pretty dense areas?
Does.
So you're probably only getting a few pictures of quite a diverse set of cities with different characteristics of scenic.
Yeah, that is exactly right. So I mean, I'm now starting to understand, with this model, where the city might be scenic. But what I'm missing, I notice, is modern buildings, and I would love to kind of create a bit more training data on the city. So actually, we're running an exercise. So we run this big data MOOC on FutureLearn, and we're going to be basically getting more pictures rated in London in general. Because I'm also very interested in architectural styles, and it's the problem with the 1 kilometer resolution is it's basically missing a lot of that kind of modern architecture, and I don't actually know how that's coming. So
Do you use something like density of photos on, say, Instagram or something to sort of weight where you're highlighting scenic areas?
I've used density of photos to see if I could predict scenicness, and it works to an extent, but sometimes people take pictures for things for who knows what reason, so it's not actually that perfect. But yeah. But anyway, I'm happy to answer anything over beer. So.
Okay, let's thank the speaker again. So much. Very quick.